This is
STEM Z Perspectives.
Hello, everyone, and welcome to the fourth episode of STEM Z Perspectives, a podcast by the Young Scientist Journal.
Thank you all so much for listening to this episode. I'm Harry, and I'll be one of your hosts for today's episode. My interests are in earth sciences, engineering, and computer science, and I'm currently in year 10 at school in the United Kingdom.
My name is Stella, and I'm interested in aviation, astronomy, and physics. And I can't wait to share with you what we have today.
Yeah, it's going to be a really interesting episode, so stick around.
Yeah, we'll be discussing some scientific advancements that happened during 2020, namely the oldest material found on Earth, the discovery of ghostly radio cycles, diversity in STEM, the accidental creation of a hybrid fish, and the discovery of remnants of a rainforest in Antarctica.
And what a year it's been. Obviously, this is our 2020 recap, and so much has happened this year. Obviously, with the pandemic, the development of vaccines, there's been so much that's happened in the world. But on a more close to home perspective, YSJ has achieved so much this year. We passed 1,000 followers on our Instagram, and we had our 8th annual conference online this year, which was a new and slightly weird experience for us all.
For sure, but all in all, it was all about exploring and learning new things. So we can't wait to recap for you. And we are going to start with the oldest material found on Earth.
Okay, so let's start off with a Cosmo chemical discovery. So around 1 year ago, in January of 2020, wow, it feels like almost yesterday, a team of scientists found the oldest material ever discovered on Earth inside the Makkaisen Meteorite.
This meteorite actually landed in Victoria, Australia in 1969, and since then has been the subject of many studies.
It's estimated to weigh around 100 kilograms, but the fact that it contains the oldest material found on Earth is not only the most unique thing about it. One thing is that it's classified as a carbonaceous chondrite. Chondrites are essentially meteorites that have chondrules, tiny round particles embedded in the body of a meteorite. And the carbonaceous part is just relating to how Makkaisen is rich in carbon.
Yeah, carbonaceous chondrites represent around 4% of the meteorites that fall to Earth. That's another interesting thing. So it's uncommon for meteorites to contain amino acids, which includes glycine, for example. However, Makkaisen contains distinctive amino acids such as isovaline, and a 2010 study found that a sample of Makkaisen had 70 amino acids. For perspective, there are around 500 naturally occurring amino acids.
Yeah, that's quite a big percentage. It has quite a complex molecular structure. I mean, no wonder this meteorite that landed 50 years ago is still studied so extensively today. It continues to surprise us and bring us closer to understanding extraterrestrial chemistry and worlds.
For sure, it's honestly astounding how much information we've been able to gather from just 100 kilograms of debris that's like the weight of a dolphin. 1 grain of stardust found in Makkaisen out of the 40 silicon carbon grains analyzed is 7 billion years old, older than the solar system by about 2.5 billion years. Incredible, right?
That is, that's such a long time, but in astronomical terms, it's really not that long. So you may be wondering, how do we know this? How did the geochemists measure that the stardust is 7 billion years old? Well, it's quite an interesting story. They measured how long their samples were exposed to interstellar cosmic rays.
This, however, doesn't give the most accurate edge, but it's still a useful technique and provides a good approximation, obviously.
Yeah, and scientists don't believe this actually is the oldest grain present in Makkaisen. There may be many that are still uncovered, still yet to be found.
True. I wonder what the oldest material we discover will be and when that time will arrive. I'm literally looking forward to it.
I mean, I hope it's going to be quite soon. Honestly, the implications meteorites have regarding the Milky Way and the universe as a whole is really fascinating. These minuscule objects can tell us so much about the formation of our solar system, as well as the formation and the evolution of various celestial objects. They also give us hints about the origin of life, so where we've come from.
I completely agree with you, Harry. It's just like when scientists found ribose, which is essentially for RNA in a meteorite in 2019. That was quite insane.
Anyway, let's continue with the second item of this episode, which is radio circles. So it's another fascinating space discovery. Woo! So in late 2019 to mid 2020, using the Australian Square Kilometre Array Pathfinder, astronomers have found space objects unlike anything seen before. And this was only reported in June of last year, so only about 6 or 7 months ago.
Yeah. When observed in radio wavelength, these objects seem to be bright circular disks. They don't emit visible wavelength light, which is another one of their unique aspects. Their origins are still unknown, and they have been dubbed ORCs, meaning odd radio circles.
Yeah, and they seem to be pretty rare as well, at least in comparison to stars and exoplanets. In their June 2020 paper, the astronomers claimed they observed 4 of these objects. In terms of all the stars in the night sky, that is a minuscule amount.
That makes it all the more exciting. I mean, who knows how many of these objects we're going to discover and what else we're going to learn about their characteristics.
Yeah, and it's a really interesting topic. There could be more out there. For all we know, they could be finding more right now, and there could be another paper in the works.
True. Something we already know about the discovered ORCs is that they have an angular diameter of about a minute. So essentially, the angular diameter of an astronomical object is the apparent diameter based on the angle the object makes with the point of observation. I would definitely recommend looking at some diagrams of these.
So where do these objects originate from? Why do they exist? There are only a few guesses about this.
Definitely. In their paper, the astronomers actually presented 11 probable causes, though some are much more likely than the others.
The first of these was that these objects are actually imaging artifacts caused by a software error. However, they detected the ORCs with more than one telescope, and 2 of them were clearly imaged twice with different telescopes. So, this is very unlikely.
The structure of these ORCs is similar to some supernova remnants of a highly massive dead star. So in the paper, the notion that they may be supernova remnants was also considered. However, this has been essentially ruled out. We don't know why.
The Evolutionary Map of the Universe Pilot Survey, which is a radio survey project that utilised and observed minuscule fractions of our galaxy, around 6 times the power of -5 of the volume of the Milky Way. So, given that they found 3 ORCs in that area, this would imply that the whole galaxy contains 50,000 of these. However, supernova events are quite rare, and only 350 supernova remnants have been confirmed in the galaxy. So, this as well doesn't seem like a very likely possibility.
This also applies to planetary nebula, which are more common than supernova remnants, but still seemingly less common than the estimated number of ORCs.
Yes, exactly. They also discuss whether these ORCs could be a ring galaxy or a double-lobed galaxy radio, but the morphology and emission doesn't exactly fit what's been observed. So, there are some discrepancies.
Yeah. They claim out of everything that's been considered, the most probable explanation is something called galactic wind termination shock. So essentially, ORCs may have galaxies in the middle of them, and massive explosions in said galaxies may have led to the formation of the ORCs, which are now expanding shockwaves.
It's quite an interesting possibility, and along with a lot of things in in our universe, only time will tell. So we'll just have to wait and see.
Definitely. to our next topic of the day, diversity within STEM sectors and education, and how much progress has been made in the past year, 2020.
First, let's look into the statistics showing the extent of the lack of diversity in STEM. According to a report by UNESCO in June 2019, only 29% of roles in research and development in science are actually filled by women. And this disparity occurs really early on, given that in certain fields, women account for a very small percentage of those studying STEM subjects. For example, just 3% of ICT students across the globe are women, 5% for mathematics and statistics, and just 8% for engineering.
These are very actually low percentages, but the lack of diversity is not only an issue of gender. An article published in the Lancet mentions that less than 20% of the UK's National Health Service identify as BAME, which stands for Black, Asian, and Minority Ethnic. And within the top tech firms in the UK, 70% of senior teams do not have a BAME member. Absurd.
And this is so unfortunate, not only because it creates stereotypes of who can be a scientist, and it presents barriers to those with potential, but also a lack of diversity in any field that affects everyone involved.
Absolutely. An increase in diversity means an increase in creativity and advancement, because a more diverse talent pool will result in better teams and better outcomes. When the selection pool is limited for whatever reason, it makes perfect sense that it will have an impact on the talent procured. A powerful statistic that backs this up from the National Center for Women and in Information Technology is that there is a 40% greater number of US information and technology patents filled by mixed sex teams in comparison to all male teams. This makes it clear that more diverse teams are more productive.
Now that we understand the importance of a diverse STEM sector, what is actually being done to tackle this disparity? One of the interesting initiatives launched last year was the I Am a Scientist program, which was delivered by the Plenary Co, which consists of a classroom toolkit for school-age students to explore the stories of real-life scientists from diverse backgrounds.
And the great thing about this program is that it follows a bottom-up approach, tackling the issue at its root rather than targeting it from above. The following statement from Georgia Gikosari, a Facebook AI research scientist, sums this up perfectly. He says, in my opinion, to promote diversity in the STEM fields, we need to change things bottom up. We need to uproot the gender bias that society inflicts on women at an early age. We need to combat economic inequality. We need to guarantee equal opportunities and high quality of education, regardless of zip code. This, of course, calls for a huge socio-political change. Top-down efforts like pressure for female presence in executive roles, workshops and gatherings which promote underrepresented groups, and other such activities are helpful and encouraging, and I fear not powerful enough to establish the change we're looking for in the long run.
This quote, it's so important, and it just shows that we shouldn't be treating people because of their ethnicity. We need to have a diverse STEM community, and I think that's something that's really apparent in organizations such as the Young Scientist Journal, because we come from all across the world, so people have so many different backgrounds, and it just
so many ideas, and it adds up, and
it makes a really more productive team, and it's it's interesting to learn about insights from other parts of the world.
So moving on to our next topic for today, accidental creation of a hybrid fish. Another interesting scientific occurrence happened in July 2020 in a Hungarian lab, and this was the accidental creation of a hybrid fish. Can you imagine?
I can just imagine. There's some rather vivid images in my head. But scientists were attempting to prove that the eggs of Russian sturgeons can be developed without fertilization, so simply in the presence of an unfamiliar sperm.
This is a type of asexual reproduction called gynogenesis, when egg development can be induced without fertilization, so that offspring ends up with 100% maternal DNA. In this way, sturgeons could reproduce quicker.
Yeah, and this would be particularly useful to investigate, as the Russian sturgeon is an endangered species and also a source of caviar.
So they picked a species of fish that they thought was quite unrelated to the Russian sturgeon. This fish species was the American paddlefish. The two species are incredibly different and have been evolving independently of each other for over 184 million years and live on opposite sides of the globe.
Yes, this means they have different characteristics and different survival mechanics. American paddlefish is a filter feeder with a long, sensitive nose that lives in slow-moving rivers. The Russian sturgeon is a carnivore. However, when they mix the two seemingly completed, unrelated and dissimilar species, a hybrid set of fish was created that actually made it through the embryonic development and survived months beyond that. That's pretty amazing.
Yeah.
The species, specific statistics for the species show the survival of offspring, according to the researchers, was it ranged from 62 to 74% just 30 days after hatching. That's quite an astonishing amount for something done in a lab
Yeah.
like that.
Definitely. That was really incredibly surprising to the aquaculture genetics conducting the initial experiment, as they were not expecting the creation of a viable hybrid at all.
They actually called these hybrid fishes straddlefish. Quite an interesting and creative name.
Unique name, yeah. The science behind why the researchers actually incorrectly predicted that a hybrid wouldn't form is quite interesting.
Yes, the species were actually perhaps more closely related than initially thought. This is because the two species of fish can be considered fossil fish species, where they have extremely slow evolutionary rates.
Exactly. This means that although we might think it's been a long time and the species would have diverged quite a bit by now, in terms of evolution of fossil fishes, it actually hasn't been that long. It's a short amount of time.
So both the Russian sturgeon and the American paddlefish still have genomes similar enough for some genes to combine to produce a viable hybrid offspring. Although to be clear, the hybrids can't be classified as a species, as their offspring can't reproduce, which is a bit of a shame, considering they've got that far with.
Yeah, very, very embarrassing and sad. Yeah, it's very sad. Also, the hybrids actually weren't all the same. Some were close to an even 50-50 genetic split between their two parents, but some had more sturgeon-like features, while others had more paddlefish features.
Although some of these straddlefish survive today, the researchers don't intend on making more. It might be something good to come back to perhaps in the future.
I I'm wondering why, because like I feel like that's something that's unique. Like they should like make more and maybe fill the ocean, even if like they can't like reproduce or something. It would really be cool. And that was like a very interesting scientific experience for these researchers involved, definitely.
And finally, on to our last topic for today's episode, which is the
Yay.
remnants of a rainforest in Antarctica. So another interesting scientific event in 2020 was researchers actually finding remnants of a rainforest in Antarctica.
Yeah, these researchers actually found buried sediment in West Antarctica that contained pollen, roots, and other fossil evidence that was indicative of the presence of a forest millions of years ago.
This sediment also provides scientists with an idea of just how warm it actually was in the mid-Cretaceous period, which was about 85 million years ago.
Exactly. The traces of vegetation in the sediment helped identify the climate conditions here. And they found that the temperatures averaged at 13 degrees Celsius with highs of 25 degrees Celsius in the summer.
Sounds a bit like British weather. To give some context, the mid-Cretaceous period is considered one of the warmest periods on Earth, and it had a higher carbon dioxide concentration that's than what's found on Earth today, even with climate change.
Yeah. This discovery of remnants of a rainforest in Antarctica was important to scientists as it changes what we thought the greenhouse gas composition of the atmosphere was in the mid-Cretaceous period.
Yeah, we thought it was around 1,000 parts per million of atmospheric carbon dioxide concentration. But for a forest to exist so far south, the carbon dioxide concentration must have been a lot higher, estimated to be more like 1120 and 1680 parts per million. According to marine geologist Johan Clage, this is because plants require carbon dioxide to photosynthesize and becoming productive enough to sustain the creation of a forest.
This revelation that a forest once existed in Antarctica was impressive to scientists. It shows scientists the significance and usefulness of carbon dioxide and what it can lead to.
Yeah, exactly. Especially as Antarctica, being so far south today, it's the South Pole. It's absolutely amazing. It doesn't have light around for 4 months of the year. So to be able to sustain a temperate climate in those conditions, it's so impressive.
Yes, and just to explain to our audience what the evidence of the remnants found were, they were actually found in ice cores. Within a 30-meter ice core discovered in the Amundsen Sea environment, the researchers found traces of roots at the bottom 3 meters of sediment. These bottom 3 meters corresponded in time to the mid-Cretaceous period, and the roots obviously indicated the presence of vegetation in this time period.
That's amazing. We associate Antarctica with just being so barren, where almost nothing will grow.
Yeah.
And as well as this, they also found pollen in the ice core, which suggested the presence of plant species like conifers, ferns, and flowering shrubs in this forest. The lack of salt traces in the ice core also suggested the presence of fresh water as well, which is really impressive.
Very, very impressive and very incredible. The vegetation within the forest means that Antarctica was once a place of greenhouse warming and absorbed more solar heat, as there wasn't any ice to reflect the heat and keep the area cool.
Yeah, so even though Antarctica is so far south, it doesn't mean it always had to be covered in ice. Although this discovery was really interesting and surprising, it's difficult to suggest how this discovery could help us understand modern climate change science and how increasing atmospheric carbon dioxide levels could affect the Antarctic.
True. Yeah, but we do still know the benefits of ice and the current climate of the Antarctic, and we should do everything we can to preserve it and prevent climate change, because climate change is one of the biggest issues the world is facing today.
Absolutely. The Antarctic has so much influence over our weather patterns, so we have to ensure its safety and its longevity.
That's all that we had for you today. We were able to explore the Antarctica, the hybrid fish, the meteorites, and we hope you got something from this. Thank you for listening to our podcast.
As always, thank you so much for listening. You can buy our official merch at shop.wise journal. Leave us a voice message, which we may feature in our next episode at podcast.wisejournal. Be sure to give us a follow on Spotify, subscribe to us on YouTube for the video version. We hope you really enjoyed this episode and it gave you an insightful insight into all these things that we've discussed today. Thank you so much, Stella, for hosting alongside me. So thank you so much for listening, and stay tuned for the next episode of STEMsy Perspectives.
Thank you.